Math 31, welcome to the last topic in section 3.1. We're going to discuss one-to-one functions. So a function f is a one-to-one function if, for elements a and b in the domain of f, a not equaling b implies that f of a does not equal f of b. And that might seem a little convoluted and make you scratch your head a little bit. And what it really boils down to, if I want to write it in words, is there are no repeated x or y values. So when you look at your ordered pairs, nothing repeats. And then if you don't have a list of ordered pairs, let's say you have a graph, we have something called the horizontal line test for that, where it says a function is one-to-one if every horizontal line intersects the graph of the function at most once. The horizontal line test can be used to tell whether or not a function is one-to-one. So if we kind of reach back to the very beginnings of this section, we were talking about relations, right? And then if you wanted to be a little bit more specific, you could talk about functions, right? And to test that out, that's when we would use the vertical line test, right? So to determine if a relation was a function, we wanted to see if it passed the vertical line test. So again, all functions are relations, but not all relations are functions. So as I move down this little flowchart, it's harder and harder to become these. So everything can be a relation, but not every relation is a function. You have to pass the vertical line test. And then on top of that, we're going to qualify these functions yet another way. We're going to talk about one-to-one functions. And these are even harder, and fewer of them exist because here you have to pass the horizontal line test. So thinking about it this way, all one-to-one functions are automatically functions, and all functions are automatically relations. But going down this flowchart is tricky. Not all relations are functions, only certain relations are functions. And then not all functions are one-to-one functions, only certain functions are one-to-one. And we get more and more properties as we kind of flow down this little graph I made for you. So functions have a lot of properties that relations don't. And the big important one, the one that one-to-one functions have, is we can find the inverse function if we know a function is one-to-one. So that's why this will become important. And we'll talk about inverse functions a little bit later on in this chapter. So we've got the vertical line test and the horizontal line test. So let's look through this and see if we can determine if we have functions and whether or not those functions are one-to-one. So we're going to take a look at two graphs here. Let me get those in view. All right. So it says determine whether each graph is the graph of a one-to-one function. So this is a little hard to see on here, but we've got what looks to be the negative cubic function. Now it would pass the vertical line test. So if I sent vertical lines through here, it would pass. It would hit, those vertical lines would intersect my graph at no more than 1 point. So I would say, yes, this is a function. All right, now on top of that, let's see if it's one-to-one. Does it pass the horizontal line test? And it does. You can see that if I pass, or if I draw horizontal lines on my x-axis, or my x and y axis, it intersects my graph at no more than 1 point, or at most once. Specifically, exactly once. So this passes the horizontal line test as well. So on top of that, it's a one-to-one function. All right, so that means there are a few more properties it has than functions that exist that aren't one-to-one. All right, so let's take a look at part B. Is this relation a function? It looks like it, right? If I send some vertical lines through it, it looks like a function. It passes the vertical line test, the VLT. All right, now let's see if it passes the horizontal line test. Can we also tack on an additional vocabulary term of one-to-one? Well, you'll see if I send a horizontal line through it, it fails the horizontal line test. So this is not a one-to-one function, right? This function failed the HLT, the horizontal line test. Okay, Let me erase my horizontal line here just so it's not in the way. So what that means is this function has a few more properties than this function. All right, it's trickier to become a one-to-one function than it is just to be a regular old function. So again, all one-to-one functions, oops, let me scooch down. I took you out of view. Do we have it in view there? Almost. So all one-to-one functions are functions, all functions are relations, but it doesn't go the other way. Not all relations are functions, and not all functions are one-to-one. And you get more properties the more specialized you get. Okay, so before we get out of here, I want to start to talk about something called our toolkit functions. All right, so there are some toolkit functions that I'm going to flip to on the computer in just a moment, but in this text, or in this class I should say, and in this text, we're going to be looking at graphs of functions. That's the main idea of coming out of Math 31, that you should be able to spot an equation, know what the graph looks like, and be able to tell me all sorts of properties about it. So when we're exploring these functions, I mean, we need to know the shapes of their graphs, their characteristics, their algebraic formulas, how to solve problems with them, and your book pinpoints these toolkit functions. It's going to talk about constants and lines and absolute values and quadratics and cubics, all those basic functions that we need to know. And I'm going to flip to my calculator, not my calculator, my computer in a bit and show you what I'm talking about. But these toolkit functions, they form a set of basic named functions for which we'll know the graph, the formula, and these special properties. And it becomes more and more helpful for you as we progress through this semester if you can recognize these toolkit functions by name, by formula, by graph, all right? And that just is going to help you as we get into the more difficult functions. Let's have the basics down so we can extend beyond those. And I'm going to show you page 174 of your text, where your text actually shows you all of those toolkit functions. So before I flip over to my computer, I just want to remind you of what we've talked about in this section. Right, we've talked about how to determine whether a relation represents a function. We use the vertical line test for that. We've practiced function notation, both by hand and on our calculator, and we just picked up the horizontal line test to determine if a function's one-to-one. And I'm about to flip over to my computer and talk about toolkit functions. All right, so that's it for 3.1. Thanks so much, guys. I'll see you in 3.2. Bye. Hey, Math 31, before we get out of here, I just want to show you your basic toolkit functions, and they're on page 174 of your text. So if you head over to your text, you can see all of them. So our toolkit functions by name, by function, by graph, and there's even some tables here. And at the end of this video, I'm going to show you how you can activate your tables on your graphing calculator, which will be extremely helpful, especially when we have to go graph the more difficult problems. So you see we've got our constant function, identity, absolute value, quadratic, cubic, and there's some more down here that I'll talk about in a moment. But your basic constant function, the one that they've specifically graphed here, is f of x is equal to 2. You can see all of the y values are 2. And you might be used to saying, well, isn't that the line y equals 2? Yeah, it totally is. But we're going to get used to using function notation. So we're going to say f of x is equal to some kind of constant, specifically 2 in this graph. All right, we've got our basic line with a slope of 1 and a y-intercept of 0. We've talked a little bit about the absolute value function. Its graph looks like that, right? We've got the v with the vertex at the origin. You have your basic parabola, your quadratic function of x squared. Just take note that all of the y values are positive. Whenever you square something, those y values are positive. Here's your basic cubic, right? F of x equaling x cubed. Here's your basic reciprocal function, and we will study this a little bit later on in the semester, but the reciprocal of x is 1 over x. This is the graph of a hyperbola. It might not be the traditional hyperbolas you're used to that you might have seen in a previous math class, but it is a hyperbola. All right, and you can see we're having a domain issue. We're not allowed to plug 0 into the denominator, so you see there's no point on this graph when x is equal to 0. Same thing down here for the squared reciprocal function. There's no x equals 0 ordered pair because we can't plug 0 into this function. It's not in the domain. One thing to note on the reciprocal squared function is that all of the y values are positive. All right, on the square root function, we run into a different domain issue. You're not allowed to take the even index of a negative radicand. So you can see here on the table of values they gave you, all of these values, all of these x values are either 0 or positive, right? You don't see me taking the square root of -1 or the square root of -2 or even -1/2. It's not in our domain. Whereas we're allowed to take the odd index of anything, which is why you do see negative numbers in the domain here. Okay, so let's take a look at, let's do square root of x. I'm going to graph that on your calculator, and I just want you to see how you can use your table function to help you with this. So let me do key press history. Let me clear that out. So if we want to graph something in here, we're going to hit y equals. It looks like I have an old parabola in there. I'm going to clear that out. All right, and I see my square root symbol right over the x squared symbol, but it's in blue, so I'm going to hit my blue key. And then I'm going to hit x, close that out. Oops, let me hit x, close that parentheses out. All right, now we'll hit zoom 6, because I don't know what my window was before. I don't remember the last time I used this calculator, so I'm just going to reset to the standard graph. And you can see that square root function right there. It looks similar to the one that we have on page 174, but I want to show you where this table lives. So if you look over the word graph, there's the word table in blue. So let me hit second in graph, and my table function gets called up. And you see it right here, where if x is 0, y is 0. If x is 1, y is 1. And here, if x is 4, y is 2. Now, this has more ordered pairs than what they gave you on page 174. I just want you to see how you can activate your table function. And I want to show you how you can manipulate it too. So if you look over the word window, there's table set. So just watch me for a moment so you can see the things that I'm going to alter. But before I alter it, just take note that each x value went up by 1 digit, right? 0 to 1, 1 to 2, 3, 4, 5, 6. Okay, so let's say I go start at 0, but I switch the delta table. That means the change in x. Let's change it to 2. Oops, not 22, geez, 2, okay? Now just watch, I'm gonna go back to my table. Do you see how now my x values are 0, 2, 4, 6? They're jumping by 2 units, right? I could adjust my table, my delta table to 5, right? If I go back to my table, now you see it's going every 5, 10, or 5 units, but 5, 10, 15, 20. And let's say for some reason you didn't want to start at 0. You wanted to start, I don't know, at -21, just because. Oops, don't go to window. Hit second in table set. Let's start this at -21, and then I'll bring this back. I'll go, we'll do every 1 unit at a time. All right, so if I hit if I hit second and table, you see that now I'm starting at -21, and I've got my delta table, each x value increases by 1. And you're more than welcome to scroll through this. It's going to take me a while. I got to get to x equaling 0 before I don't have a domain issue. All right, but I just want you to see how that table function works, okay? So we've got a little bit more on how we can graph in here, how we can use our table, how we can set our table, and we want to just become as efficient as we can with these calculators, so that the calculators are doing the bulk of the technical work, and then we're interpreting things. All right, so with that ends section 3.1. I'll see you in section 3.2. Bye, gang.